Hi all, in this session we are going to learn about Azure Kubernetes Service. Here we can learn what is Kubernetes Service, how to create it, where we are going to use it, everything we are going to discuss in detail in this session. Let us quickly understand what do you mean by Kubernetes Service. Here it's a basically container orchestration tool. Means with the help of the Kubernetes service we are going to control the containers. Generally what you know about the container, it's just like a alternate to the VM. So here either we can be deploy our application on top of the virtual machine or on top of the container. Because of the advanced features offered by the container, the companies are showing the interest towards to host their application on top of containers, because of if it is a microservices, then the container is the best and one of the best option in order to host their application instead of making the application as monolithic. These things we had already discussed in the last section, like what is monolithic and what is microservices. Let us ignore about that and come to the topic regarding Kubernetes services. Here it is a basically container orchestration tool and it is open source. What do you mean by open source? Means it is freely available in the internet and which is used for deploying and managing the containerized applications. Means whenever we host our application on top of the containers, then we can call as containerized applications. Means we host our application on top of containers. That's why we are calling it as a containerized applications. The functionality of Kubernetes service are container deployment, container scaling and descaling, creation of pods, and load balancing. Here you can be able to develop and deployment running of your application with the Kubernetes service. It is going to provide such kind of flexibility. And one more thing guys, the Kubernetes service is not a replacement of Docker. Here in this case we can consider the Kubernetes service is an alternate to the Docker swarm. Generally why we are going to use the Docker swarm? If you have one service, if you want to run the same service in the multiple nodes, not containers, in multiple nodes, then you are going to use the Docker swarm. The same funda will be applicable here. With the help of Kubernetes service, you are going to run your service on multiple nodes. Here node is nothing but a virtual machine. And this was introduced by the Google. Means the Kubernetes service was introduced by the Google and it has been written in the Go language. And later it has been donated to the CNCF, stands for Cloud Native and Computing Foundation in the year 2014. And the Kubernetes v1.0 was released in the 21st July 2015. And the current stable version is there are a lot of versions are there and it is going to change on day by day. So let us have a look on while creating the AKS cluster. We will have a look on what is the default version right now which is available in the market. So here please understand the guys. So this is the architecture, how the Kubernetes is going to maintain the application at the cluster level. Generally I'm going to make the screen marker here, so then I can make some kind of wonderful presentation. So just take it here. First of all, what do you mean by cluster? Cluster is nothing but group of nodes. What do you mean by node? VMs or virtual machine. Here a group of virtual machines will be called as a cluster and the Kubernetes is going to operate at the cluster level. Okay guys, AKS service, that's why we can call as Azure Kubernetes Service. So the AKS is going to operate at the cluster level. Cluster is nothing but group of virtual machine. Instead of cluster what we have? Nodes. So here nodes is there, means virtual machine. Inside of node what we have? Pods. Pods are nothing but a smallest deployment pod. Pods are different, containers are different, because of one pod can have multiple containers and Kubernetes cluster is going to deal with the pod only. Kubernetes cluster is never directly communicate with the container. It is going to deal with the pods only. And container, as you know, what do you mean by container? Container is just like a virtual machine and on top of the container I can be able to run my service. Simply understand this diagram guys. So you have a cluster, inside of your cluster you have nodes. On top of nodes you are going to create pods. On top of pods you have containers. On top of container you are going to run your service. This is the architecture. And come down here. Okay, so this is the architecture, and here we have two things are there. One is master node and the second one is worker nodes. Here you can maintain one or two master nodes based on your requirement. If you want to make the master node as highly available, you can maintain multi master nodes as well. Suppose if you are okay with the single master node, then you can continue. It is purely your requirement. And nodes, how many nodes you want in order to host your application or in order to run your application, based on your requirement you are going to choose that particular number of nodes. But backend this will happen. So if you create any kind of AKS cluster in backend, we have two things are there. One is master node and the second one is worker nodes. Generally, you know what is the relation between the master and worker. The master is going to control the cluster and it is going to allocate the work to the worker nodes. Means the workers are going to work under the master plane. Whatever the commands which comes from the master node, the worker nodes are going to execute the commands. Okay, fine. Let us understand in detail about the each and every component of master and node. So here you have the multiple things. If you observe in the master, we have API server, etcd cluster, control manager, kube scheduler. Each component has a different purpose. It is going to work for a specific purpose. And coming to the node, we have kube proxy, kubelet, docker engine or container engine, pods. Inside of pods, what we have? Containers. On top of containers, we are going to run our services. And kubectl is the command way in order to communicate with the cluster. So if you create the cluster, you just need to communicate with the cluster in order to make your requirements. So how you can be able to communicate? Either you can be able to communicate through graphical user interface or through command line. With the help of the kubectl command, you can be able to interact with the AKS cluster which you are going to create. How that will be, everything we are going to discuss in the next upcoming sessions. Don't worry guys. Just first of all, please focus on what the things are happen. Like what is Kubernetes, what are the components are there, how the flow is there. Just please focus on this theory section. Once we have completed the theory section, we will go to the practical session. So this is the architecture. If in an interview, if anybody asks you, tell me the architecture of the Kubernetes, then you need to explain all the scenario. You have the cluster, inside of the cluster you have nodes, inside of the nodes you have pods, you have inside of the pods you have containers, inside of the containers you have services. And coming to the architecture, you have two different things are there. One is master node and the second one is worker node. In master node you have four components, that is API server, etcd cluster, control manager, kube controller. And coming to the node, you have kube proxy, kubelet and the docker engine, you have pods and you have containers. So let us deeply understand about the different components. Just come down. Okay, here before discussing about the components, first of all we just need to understand about the key features or advantages of Kubernetes service. Even though we have the Docker Swarm, why we are going to adapt the Kubernetes service? Because of it is a heavy service and it is one of the expensive service in the Azure. So whenever, why we are going to use such kind of service? Because of if I am going to use any kind of service, it is going to provide such kind of advantages to me. Based on the advantages which I will get by using those specific services, accordingly I am going to use those services. Here what kind of benefits I am getting by using the Kubernetes services? Let us have a quick look on it. Here automated scheduling means the Kubernetes provides the advanced scheduler to launch containers on cluster nodes based on their resource requirement and other constraints while not sacrificing the availability. Means it is going to schedule the pods whenever there is a requirement happen. Based on the resource availability, it is going to schedule the pods on the worker nodes. Self-healing capability. What do you mean by self-healing capabilities? Means if any issue happens to any of the ports or nodes, then it's itself only it can be able to clear that issue. Means it allows us to replace and reschedule containers when nodes die. When suppose when one of the node is not available, suddenly it is not responding, then what it will do, it also kills containers that doesn't respond to the user defined health check and doesn't advertise them to clients until they are ready to serve. Means whenever there is issue happen, it is try to fix those issues. Even the node is not reachable, even the container is not reachable, it is going to understand, okay, so and so node or so and so pod is not working, I need to replace it. Then without having the manual efforts, it is automatically can be able to self-healing capability by using the Azure Kubernetes Service and automated rollout and rollbacks. What do you mean by rollouts? If you are moving to the next version, that will be called as rollout. If you go back to the previous version, that will be called as rollback. With the help of the AKS service, we can be able to make the automation of rollout and rollbacks. If it is succeeded, then we are going to make the rollout. If it is failed, then we are going to opt the rollback service. Horizontal scaling. As you know, what do you mean by horizontal scaling? Increasing of containers. Whenever there is load is increasing, in order to meet the increased load, we need to make the containers more. We need to increase the count of containers in order to load the incoming traffic. Then one of the scaling method is horizontal scaling, means creating of another resource. Load balancing is possible with the help of the Kubernetes service. Whatever the traffic which has been come to the AKS cluster, it is going to distribute the load among the backend servers or node pools. And service discovery and load balancing, there are a lot of advantages which we will get by using the AKS cluster. And as I had already seen the last diagram regarding the Kubernetes architecture. Here we have the Kubernetes master and here we have the master nodes. Either you can be able to interact with UI, means user interface, graphical user interface, or through command line interface, that will be called as kubectl. Fine. Here let us understand each and everything components. First of all, what is mean by web UI? Web UI. Dashboard is web-based Kubernetes user interface. We can use the dashboard to deploy containerized applications to a Kubernetes cluster, troubleshoot our containerized applications, and manage the cluster itself along with its available resources. Means if you are going to manage the cluster through graphical user interface mode, then it will be called as a web UI. Instead of maintaining through graphical user interface, if you want to make each and everything through command line, then this is the thing, kubectl. Here this is the command line configuration tool for Kubernetes which is used to interact with the master node. Generally, which node we are going to make the communication? We are going to make the communication with the master node. Whatever the configuration has been applied to the master node, the same will be applied from the master node, it will be applied to the worker nodes. What do you mean by master node? The master node is responsible for management of Kubernetes cluster. It is mainly the entry point for an administrative task. Means whatever the administrative task I want to perform on the cluster, with the help of the master node only I can be able to perform. Means it only handles the orchestration of worker nodes. Means from master node only we are going to control the worker nodes. And control nodes or worker nodes, what we have? Our application or services are running on top of worker nodes only. Means inside of worker nodes we have pods, inside of pods we have containers, and inside of containers we have services. Master node components. Let us have a quick look on different master components. Here first thing is API server. It is used, the Kube API server interacts with the APIs. Application program interface. It is the front end of the Kubernetes control plane. Means whenever you want to communicate with the cluster, the API service is going to provide such kind of communication feature By using this API server, you can be able to communicate with the cluster. Scheduler, as you know, in the name itself suggests it is used to schedule the pods. How the scheduler is going to watch the pods and assign the pods to run on specific host. Means from master node, we can be able to schedule a pod on any worker node, which comes under the master node. And the scheduler will try to schedule the unscheduled pods in the nodes with the help of kubelets. And what is the thing? etcd. etcd is nothing but it's a kind of key value data store. The Kubernetes will maintain all the cluster info like nodes, pods, services, volumes, everything in the etcd only. Means it is kind of storage device, means storage thing. All the configuration of the cluster is going to save in the etcd only. It is kind of a database for the Kubernetes. It's simply distribute key value store. The Kubernetes uses etcd as it's a database to store all the cluster data. Whatever the data which you have, which is related to the cluster, we are going to save all the cluster data in the etcd only. It is just like a database for our Azure Kubernetes cluster. And worker node or slave node. And what are the components in the worker node? We have the kubelet. What do you mean by kubelet? It is a kind of agent that runs on each node. It is used to make the container is healthy and in the running state, and at the same time it makes the manifest file. Because of here we are going to use the manifest file. Manifest file is nothing but a YAML file. That is nothing but a configuration file. Here whatever the things which we want to execute, we are going to create one file that is nothing but a manifest file. Whenever we had applied that manifest file to the AKS cluster, it is going to create the required services which we want to run on top of AKS cluster. That is the basic purpose. Kubelet is the agent which is going to run on each node, or we can call as worker node. Kubeproxy. What is the purpose of kubeproxy? The kubeproxy enables the Kubernetes service abstraction by maintaining the network rules on the host and performing the connection forwarding. Means it is going to take care about the networking part. The kubeproxy maintains network rules on nodes. If you want to define any kind of network rules and it is going to implement on the nodes, then with the help of the kubeproxy, you are going to maintain the network rules. These network rules allow the network communication to our pods from inside or outside of our cluster. Means how your pods want to communicate to the external world, to the internal pods, everything will be decided by the kubeproxy. Here you are going to maintain some kind of network rules. So how you are going to define the rules? Accordingly, the pods will be able to communicate. Okay, it helps us to have a network proxy and load balancer for the services in a single work node. Okay, there are a lot of things, sir. And here the container runtime. Each node must have a container runtime, such as Docker or RKT something. Means here if I want to create any container, first of all, what I need to do? I have some kind of container technology tool. Here the mostly preferred the container tool is Docker. That's why the containers will be called as a Docker containers, because of it is the first company that has been introduced the container technology. So here if I want to create the container, first of all I just need to have any kind of container engine. Here the Docker engine is the one of the containers tool which are going to use in order to create the containers. Okay, and the AKS, Azure Kubernetes Service. It is a managed service that allows us to quickly deploy and manage clusters. Means what do you mean by cluster? Group of missions or group of virtual missions. And it is a open source that we had already know, and deployment or management and scaling applications. Means we can be able to scale our application when there is a requirement. We can be able to descale the application or resources whenever there is a low traffic is there. So just like how we are going to host our application on top of VM and we are going to set up the load balancer each and everything, in the similar way we can be able to host our web application or our web application on top of Azure Kubernetes Service, and we are going to provide such kind of high advanced features. This is the diagram, you can refer it so in order to understand better. So this is all thing about the Azure Kubernetes Service. And one more thing guys, while creating the AKS cluster in Azure, we have to consider these following things. Like we need to set the Kubernetes cluster name, we need to set the region, we need to make sure the availability zone. So these all, what do you mean by availability zone? We had already discussed in the previous sessions, like virtual machine scale set. There are a lot of things are there. So how we are maintaining the availability zone, like so high in order to make the application in highly available manner. So you are going to select the availability zone, and we need to select the Kubernetes version, we need to select the node size, we need to select the node count, we are going to maintain the node pools, and how we are going to access control based on the role, and how we are going to integrate the AKS managed Azure Active Directory, how we are going to do how we are going to make the network configuration. These all things we are going to learn while I am going to create what Azure Kubernetes service. So in the upcoming session, what I will do, I am going to create one AKS cluster. In that session, we will have discussion on all these things. So what the configuration I am going to take each and everything we are going to discuss on the upcoming session. Okay guys, this is about the theoretical session, and I hope you guys have some kind of understanding what Azure Kubernetes service is. Then once we are doing the lab activity, that you will have some kind of clear cut picture what exactly flow is happening, how we are going to controlling or how we are going to deploying application on top of AKS cluster. Then you will understand each and everything. Okay guys, and okay guys, thank you for joining, and thank you for your support, and I will meet up you in the next session with a new topic. Until signing off, thank you, bye bye.